be very old. We need to know that what is the health of every bridge or maybe building. That is also one of the aspect. How we can measure it? Different sensors we can use it. So many ways. Okay, using all those sensor interface, we'll get a lot of data. Optical sensing is one of the leading element in the structural health monitoring. Capacitance sensing is another leading structural health monitoring. From all these things, we'll get either electrical output, and that output will be converted into digital. That digitized data will get. That digital data has to be processed through our machine learning algorithms. The whole data of that after the bridge connection and before that it get collapsed over the years of 100 years or 200 years, we need to get that proper estimation of that, how it was built, what are the ingredients in what type of materials they used, what is the strength of materials. All those aspects, if you can consider before construction and after construction, and will make a good estimation of the life cycle for the structural health. Even for automobiles also, we need to identify that the health monitoring of automobiles, how long the engine will work. We are giving lifetime for each and every element. That lifetime earlier they used to give very less because lack of knowledge on the materials used or maybe supplements given to build something. Okay, that knowledge and all everything has to be analyzed from the machine learning. And smartphone detection and perimeter access control, radiation levels, one of the important factor due to this radiation level, uncontrollability on this radiation level, electromagnetic level, and noise in urban. Okay, radiation, EMIs, electromagnetic interferences, and noises. Noises in urban areas creating a lot of health issues. These things has to be monitored and the supplement or maybe the remedy has to be identified. And traffic congestion and lot of time getting wasted in the traffic congestion and smart roads. The road has to say that has to become smart enough to. Nowadays we are getting the battery or maybe electronic vehicles or electronic and electrical with a smart battery systems. They are getting it. And the battery has to be get charged on the road itself. That is a smart roads, and warning messages has to be given using some radar chips and a radar sensing element. We have to make it and avoid that accidents or maybe avoid that unconditional things happening to the automobile users. So can be done using smart roads and smart lighting and intelligent shopping, noise in urban and map. And one of the most important things is that water leakages and water monitoring. Okay, how many water tanks are there within the city? How much water consumption is happening? All this can be done in machine learning. Here, whatever areas I am showing here, these are the few major areas, and within these areas again we can come up with some 100 number of independent aspects we can consider. Okay, the soil moisturing we can do in a forest, deforestation, and how many types of plants are there and how they will grow. And within this forest or maybe agriculture area, we can go deep into that and we can segregate into multiple subsections, and each subsection we can work out a lot. There are, and vehicle auto diagnosis, we need to find out that some collective information has to be taken. Okay, the bus or maybe car, and what is its condition and when it is going to get repaired, or maybe when the tires got changed and automatic change of the tires, or maybe engine parts, or maybe few things in automobile or maybe in industrial machines. Few things will get changed due to mechanical vibrations. Due to mechanical vibrations or maybe to the running status, few elements are going to be changed frequently. Those elements we have to identify, and if you can diagnose, if you can suggest that this has to be changed. So and so 4 years back the tires got changed, and now the status of the tires condition is this, and we have to replace it. Some kind of analysis has to be done and given. That is also important. And waste management and smart parking, golf courses, and maybe the grounding areas maintenance and water quality maintenance. One of the most essential thing in the world is that water. Without water, without oxygen, we cannot work out. That's why I'm stressing more on air pollution and water management. Okay, water quality measurement, the study of water sustainability in a rivers, and the sea for fowls, and eligibility for drinkage use. How much of water is there in the world? How much is we are able to using it, and how much water percentage? Out of 100% of the water availability, 2.4% only the water is a potable or maybe usable water. You cannot say that potable. It's only 2.4% out of 100% of the water availability. The total earth is with the water. 2.4% only the using water. Within that, almost 2% will use it for the industry purpose and irrigation purpose, in agriculture, or maybe in very aspect. The drinking purpose very less. The consumption is more, but we are having less usable water. Remaining all salt water only. On the sea, we are having almost 97.6% of water in this. It's a sea water only, which is not useful much. Okay. Then in this water quality management itself, again, so many things we have to consider. How many rivers are there? How much water is getting mixed with the sea water? And what is the drinking ranges, and what about that paddy use case of water, and different ways that using different levels of the water quality, we can use it for multiple applications. If it is having some TDS level, total dissolved solvents, very less, we can make it for drinking. If a more dissolved solvents are there, that means the hardness is more, and that can be used for the plantation purpose. Even for the plants also, they won't grow in a different salt concentration levels. That has to be monitored. So much of channeling can be done in this water quality and make it out. The Internet of Things are having applications many areas, and now by 2020, if you see that 50 billion devices are connected. 50 billion devices. Now it has come to the million number of IoT devices are there. All those million number of IoT devices are giving data. Data from IoT. This IoT data has to be analyzed. Okay. All this can be grouped together. All IoT applications nowadays, they are merging together and making out the effective world which can work it for the special use cases. Okay. More than applications, what they will show that many applications for IoT applications, they will say that new business models will appear if you are having lot of data. So many opportunities are increasing. The exponential growing number of objects connected to the internet is changing completely in our world. More number of devices. Okay. Okay, there is a Google. If you can open your mobile, and once you brought a mobile, you will register to either Facebook or maybe Google. Google is an essential thing, and the Gmail you will interconnect, and all this data is going to Google server. See, in this world, almost 800 crores of people are there. All those 800 crores people are, at most 500 crores people are using mobile. All these 500 crores, and some people are having multiple number of mobiles. Some people are having one or two or three mobile according to their business point of view or maybe requirement point of view. All these things are connected to the server. It's a maximum number of elements are connected. The whole data is stored in the server. Okay, in this, the business models will increase when you have good interface and interconnecting to the devices with the internet, and which processes can be optimized. Now we are looking for opportunity or maybe the solution. The optimization has to be done, interfacing so many things, and all are connected to the cloud, and we want some particular data. Then one of the best example is that in Amazon, we are looking for some to buy pen, and according to your requirement, after one or two trials, it will show you the different pens, even expensive. If you are, it will understand automatically. Are you looking for expensive pen or maybe inexpensive pen? Are you looking for some red color or blue color, or maybe short pen or long pen, or modern one or maybe the oldest one? Automatically, it will do that. Good optimization has to be done for that. How many vertical markets are benefited? So many markets, so many areas. The IoT applications are benefiting to many aspects. Market Trends has released the document greater than 50 sensor applications for a smarter world. More than 50 sensors, many sensors getting interfaced and working out. Okay, the total list, whatever I shown here, I categorized into 12 different verticals, showing that how the Internet of Things is becoming the next technology revolution. And within this 12, again, we are having multiple elements. The 12 elements are trendy scenarios used for smart cities is one, and where sensors offer us services like smart parking and measuring the climate change and environmental protection, water quality, CO2 emission. Okay, this climate change measurement, and within this protection, water quality, CO2 emission, and oxygen levels, moisture level. Okay, moisture levels also has to be considered, and the number of dust particles counting has to be done. That's how there it includes that water levels also will change. Okay, this climate change is another vertical in the group list, and smart environment is the key element nowadays. Everybody is looking for the smart environment where they want to have multiple elements which are going to helpful for them without any disturbance. Okay, or maybe for the comfort, people are looking at with the smart environment. Industrial control. For an automation purpose, we have to use so many number of elements, and all those things has to work together. It's not like in industry, if you see that big industries, you will be having so many sensors, data has to be collected, and based on the sensor element, if any one sensor is not responding and there is no interconnection, or maybe without interconnection, if one sensor is not working, the whole process and the lot of raw material will get wasted. All this industrial control for automation purpose has to be connected together and make it effective. Okay, logistic and retail cover applications more focused in processes effectively, like providing good information. Okay, and Amazon and Flipkart, you will get more use of this logistics and retail, even transportation also. Okay, smart metering, security, and emergencies. Okay, in a power plants, smart metering is most important, security is important, emergencies has to be the important thing, those things has to be covered. And smart agriculture, animal farming, domestic, home automation, and finally, the final one is e-health. This is a e-health. Health is the most important thing. Okay. This 12 I am giving: smart city, smart environment, smart water, smart metering, security and emergencies, smart retail, logistic, industrial control, smart agriculture, smart animal farming, domestic and home automation, and e-health. This smart animal farming also most important. Nowadays we see that this farms also has to be made that when the vaccination has to be done for the cattle. What is the health of the cattle? Health cattle also has to be done using machine learning. This is the situation we are having that. Okay. So in the smart animal farming, we need to see that when it got ill, and based on that its life cycle we can estimate what is the lifetime of the animal. Okay, what is its production value on a daily basis, per monthly you want to analyze, and how much it is eating. Even for human beings also how much they are eating, that also has to be counted. What is and even for the human beings in the health aspect point of view, why the health variations, health problems are coming. Above all these things also important, and at the same time the human what he is going to consume, that consumption of that, depending on that what he is consuming and how much workout they are doing, he or she is consuming, he or she how much workout they are doing. That whole monitoring of the person is most important to improve e-health. And e-health is that on online they can give suggestions. Earlier during the corona's time we have seen that the e-health has improved a lot. Meeting a doctor and greeting the doctor, and the doctor is giving suggestions or maybe giving a prescription and online order, everything. For the last 2 years we see that so much of change. Before 20 and after 20 we have seen that so many things have become smart. All these things also, once all these things are achieved, smart city achieved, then we can get smart country and a smart country to smart world. Within the smart cities, what are all the requirements? I am taking into that slowly from a wide area IoT to some smart cities. Within the smart cities, what we can look at? Smart parking. In the smart parking, you will get a lot of data. Where all parking lots are there, how many cars, how much space is there, what kind of car is parked. These are all, if you can make out the smart parking and structural health and noise urban maps and smartphones detection, electromagnetic field levels, traffic congestion, smart lights, waste management and smart roads. Like this, if you can make it out, then what will happen? You will have a good security and safety. And the most important thing to develop the smart cities is that to reduce the raw material wastage. Unnecessary production will reduce a lot. And this is how the smart parking IoT applications look, that where the space is empty or not, the data has to be given over here. As a computer science or maybe data science engineer, what you have to look? You have to get the data. Where it will come to that? One of the node. This nodes data you have to monitor. Obviously, within a parking lot, almost from 4 storage building or maybe 20 storage buildings will be there. In India, we are having in some smart cities 4 storage buildings or maybe 8 storage buildings for the parking. In foreign, used to US and UK, they will be having 12 storage building or 20 storage building for the parking. Unnecessarily after traveling a long time, they want to park their car in a 12 storage. Once they go to the 12 storage, if they don't find the time, lot of time and fuel consumption, their raw material wastage is there. To avoid all those things, we are developing that smart parking system. In this smart parking system, we have to see the nodes will collect the data whether the space is empty or not, parking space. Once you get a space, that information will be displayed at the ground level, and that information will be taken by the user. Even within this node information to user information also, how it will work out. Automatically it has to sense the node without any human intervention. It has to happen. When the car comes, these automated cars are there. When the car comes, auto drive cars means the person will get down at his location. The car has to move to the parking lot, automatic car, and this car will have some sensor to read the data nearby where the parking lot, and from the data it starts to read and get a space. Once the space is there, it has to go. And at the same time, this car should have a contact with the owner also, owner or maybe whoever booked this car. Okay, this is how where we can have the efficiency increment for the electric cars, and at the same time at the cars charging. Nowadays we are having smart automated cars which are battery operated, and the battery has to be charged, self-powering. It has to take self-powering also. Okay, different models they are making it now. This is other type of model where this smart parking sensors communicate with their gateway via radios, and they have to get. And outstanding power management and over-the-air program OTA model has to be installed such a way that automatic charging has to be done. Now, new model of the proposal has come to create automatic charging, and the systems evolve towards the integration of customized IoT projects specialized in vertical applications to monitor the water level and water quality. During the rainy season, what is the water quality you will get? I am showing here all the data elements. What kind of data elements we have to monitor, process, and do this. Okay. Here you have to collect the water level. Water level you need to collect for a longer duration, and water quality has to be collected. Water quality has to be collected, and TDS has to be collected, total dissolved solvent, and saltness has to be connected. And within this TDS you will have so many elements. TDS, total dissolved solvent. In a water, you might see that when it is traveling all the way, it is mixed up with either mud or maybe some particulates or polluted elements or maybe non-polluted elements. Altogether, the water will be mixed up with so many dissolved solvents, and all those dissolved solvents you have to know that, and at what flow rate it is coming. The flow rate you have to monitor. See this, so many parameters will come. When you want to look into this aspect of only to the water level management or water management point of view, you can see that these are all aspects. Within this system here, the located system on the water, what are others we have to monitor? Again, power you have to monitor. This is a solar connected. If it is in the middle of the sea or maybe middle of the river, frequently we cannot charge. Automatic solar powering has to be done. Is it a balanced charging is happening to the battery or not? Battery management has to be done. Battery level monitoring has to be done. The system is working or not. And the wireless connectivity has to be measured. Okay. All these parameters has to be read and stored and has to be analyzed. Based on that, some prediction either the gates has to open or close, and this has to be supplied to, this water has to supplied for the drinking purpose or maybe for the other purpose, for use cases in paddy fields. Can we make it useful or not? That monitoring has to be done. Okay. Several disruptive technologies has to be made to control the water quality, and that is the most important thing used in this world. Smart environment, forest fire detection, and the environment should have good control of the gases, combustion gases, and primitive fire conditions to define by having alert zones. Okay. Air pollution, what is it? Pollution emitted by cars and toxic gases and automobiles, okay, factories in a particular location. In each and every location where humans are living, and all the locations, if you want to place one sensor, so many sensors will come, and including all these sensors data, interconnecting is one of the most important thing. Okay, and snow level monitoring in abroad, here in India we cannot see, but rain level monitoring we have to do. We see that some predictions we have to make. What is the rain level? That in a real time, the quality of the rain, or maybe some avalanche prediction, or maybe avalanche prevention, we can take the some prevention when you know the rain level monitoring. Rain monitoring and landslides and avalanche prediction for monitoring of soil moisture, vibrations, earth density to detect dangerous patterns in land conditions. For all these things, we need to identify that parameters. Those parameters we have to analyze. Earthquake early detection, disrupted control in specific places of tremors has to be identified. What is that air quality IoT solution for a quick report when you see air quality, pollution, acoustic and noise level, waste management? If you can make some device like this is a antenna to transfer the data, and the sensors, I'll indicate yes as a sensor to monitor this, all these elements. We have to come up with one device. This device we can call it as IoT, which is having interfacing of microcontroller, antennas, and several sensors, whichever are our requirements to be measured. Okay, and based on that, this IoT device can be developed. And Internet of Things in a collaborative way, if you see that the key dimension can collaborate on a key dimension such as environment protection, urban planning, social cohesion, and risk prevention is one of the important thing. Aim to improve control on environmental emissions and sound pollution as a key factors, and combat climate change and prevent the impact in the citizens' health. All these things, if you can monitor and make a proper estimation, some analysis, what we can do, we can improve the health ratio or maybe the lifetime of the humankind. Okay. Sensor inside to air quality index solution kit. So many development has been done. Smart green city solution kit is there, and sensor inside air quality index basis kit. All these kits are having interfacing together to get a lot of data. Okay, with all this data information, by doing some good analysis, we can come up with a nice environmental creation. Okay. Other one is that the forest, generally in a summer, this is going to happen. I'm talking about only the forest because in smart cities we don't see that huts. Generally, in the villages, you will be having huts. In the huts, the fire accident chances are more based on the temperature conditions and the past experience. We have to predict and send information to some analyzing area. On the ground truth, I can say that at the particular location only, we have to give information. That level development has to be done in a ground way, such a way that where we can provide the people right information at the right time at the right place. That level improvement has to be done. Capability to have alert management and to deliver early warning alarms to reduce the damages. Okay. Sensor networks to monitor air pollution in several cities. When you have a cars like this, and in each and every location you will have sensors and that monitoring, and this monitoring data has to be paced, and based on the pace of the pollution level, we need to make some warning over here. What all elements we are going to monitor and measure at the sensoring air quality monitor sensor system? Okay, the quality of the air, what we breathe, okay, that depends on this nitrogen level, CO2 level, CO level, methane, CH4 level, H2S, ethanol, propane, butane, isobutane, toluene, okay, all these things, and what is the level of O3. Okay. All these things will affect the air quality, and how can we take a remedy for this? What is its each and every intensity value? That intensity value you have to identify using IoT system. This is one of the company in Lebanon, they have developed this, which can measure 6 parameters, and these are having GPS tracking, and the data has to be transferred. Generally, we see that in India, many people are finding the place where they are having only the data. They can say that D1, the table they will be giving, okay, D1, D2, D3, something, some passcodes they will make it out. Based on that passcodes, they will be having that data. This data will be given to our analyst. What our analyst will do, some modeling, they will make it out, and they will give a predicted results to them. And after that, they will decode it and measure this, what is this temperature, relative humidity, carbon dioxide, carbon monoxide, nitrogen oxide, and these elements, what they will do, the location where it is, where this pollution is happening. These details, we are going to do that. But the engineer, whoever performing this operation and making some prediction, he doesn't know that where is that location and for what he is doing that analysis. They'll give some predefined data analysis. Okay, they'll have some values V1, V2, V3, V2. They'll ask us to estimate that V1 and V2 are greater than or less than the previous data and this data. Some comparison analysis only we have to do. When people have done this comparison analysis and they made the data and segregate and divide this whole data into one is hazardous, non-hazardous, or maybe according to our point of view, okay, high and low, low and high, that prediction they will give it. Okay. This, if you work most, we see that we are not having more knowledge on that where we are working out, because we are not involved in that what we are doing. Okay. The sensors data they will give from all these nodes, whatever sensors data you will receive, See here almost 5 nodes are there, here 60 nodes are there. All these 60 nodes data will come here, and our engineers are working at this 60 elements data and so doing some prediction. Some statistical analysis only they are doing with the machine learning using Python language. When they do this, they'll segregate that this is how it is having that comparison, and that is given back to the managing team, whoever gave this work, and based on that data given back, and here they'll take some remedial action for that, how to reduce it. Okay, so the main concept in Make in India to develop such kind of things here to get raw data. Okay, raw data will come from here. The raw data will come from here. After that raw data, some processing element or maybe processed data or encoded data only we are working out. That encoded data will come from this raw interfacing of all the sensors, humidity sensor, temperature sensor, CO sensor, and here these elements, each and everything is a sensor. This hardware implementation and understanding that hardware also most important. And smart water, potable water monitoring, quality of the tap water in cities, and chemical leakage detection in rivers. Any leakages were there, or in that leakages do they, nowadays the world is having that worldwide, third world war chances are more. When the third world war comes, the severity will be more and more. Why? Compared to first world war and second world war? Because the bio wars will come. When the bio war comes, the air will get contaminated with the biological reagents. Even water will get contaminated with the biological. These two are the essential for the human being. That has to be monitored and filtered and then supplied. That detection of chemicals into the river water or maybe into the tank water has to be measured in a future. And the swimming pool remote measurement, control remotely the swimming pool conditions to avoid wastage of the water. And pollution levels in the sea has to be monitored. Nowadays, the more cities and more countries are depending on the seawater by doing desalination. Okay. Desalination process only they are getting a potable water. That is the most realistic. That's how the seawater should not get contaminated or polluted. That has to be taken care. And water leakages, detection of liquid presence outside the tanks and pressure variations along with the pipes has to be measured. Then we can avoid water leakages. River floods, monitoring of water level variations in rivers, dams and reservoirs has to be monitored. The smart water platform has to be placed like this and the data has to be processed. The challenge is choosing the most reliable and cost-effective solution for a specific application along with the processing speed, processing time. The processing time should be more important. And the Proteus water sensor for real-time detection and E. coli bacteria in rivers. Okay, this E. coli and fecal coliforms will be more dominant in the seasonal way, and that has to be monitored in lakes, rivers, and water ponds. Okay, and marine bathing waters, and maybe in a water canals also. We have to see that the quality of the water. Everybody will say that only environment and fashion only, or maybe entertainment aspect only, the sensors data will come and that only has to be processed. Now with this you can say that so many elements are there to process the data. Okay, drones, sensors and blockchains for water quality control in the Volga River to promote the trustworthy data and the transparency. Okay. They're using drone technology to monitor the water quality and maintaining some security also using the blockchain technology. What is the water level in the Volga rivers? Even in our country also, we have to look into that, embedding a lot of sensors and getting the data. Okay, the smart water and the smart water ions sensors used by the drones in the Volga system, where this drone will go into particular location that will dip the sensors inside. You see this? That will dip the sensors inside, and it will collect the data and it will come out. The technology has been developed like this using the drones. Those who are want to work on drones, or maybe giving some essential needs of the drones, they can use this drone technology for the water quality monitoring in this way also, not only for the avionics or maybe for other applications. Generally, the drones use cases, they used to say nowadays in agriculture they are doing it. Okay, agriculture and medical medicine deployment or maybe medicine supply in nearby locations. But in agriculture aspect, along with agriculture aspect, water level monitoring also we can do by making a camera sensing or maybe water quality sensors and ionic sensors interfacing. We can make this smart model to get a lot of data. And to get immediate data and process data, we have to develop a system such a way that it can do good analysis over there. And smart metering, smart grid, electrical applications, tank level monitoring, photovoltaic installation, monitoring and optimization of performance in solar energy plants, and water flow, and silos stock calculation, measurement of emptiness level and the weight of the goods also has to be done using our machine learning technology. Okay, in the fish farming, and fish farming also essential thing in many countries like Vietnam. You see that they will be having lot of sensors in the fish farms, and they'll do the continuous monitoring of the water. Water and fish quality has to be controlled. Temperature, conductivity, dissolved oxygen. Oxygen is an important factor for the fish health, and oxidation reduction potential and pH level. If pH level is not maintained, also fish won't get survive. Okay, so some device has to do the regular monitoring and transfer the data to the database, from the database to cloud server. From the cloud, will give good analysis on that, and will take a protection on the farming also, fish farming. The water quality has to be monitored. In a small gadgets, see, the gadgets like this in a household purpose or maybe in a aquarium based devices also, we have to see all these levels: ORP, oxidation reduction, pH value, EC, and the total dissolved oxygen, and the temperatures. So what is the temperature you are maintaining to save the rare elements also. Okay, rare animals or maybe rare creatures. To save the rare creatures, we have to use this sensor. All these are connected to the cloud. Security and emergencies in perimeter access control, liquid presence and radiation levels, explosives and hazardous gases detection, and these are also different sensor devices located. From all this we'll get data. Okay, what is the emission rate, what is the air flow rate, what is the water flow rate, and how much radiation emission is happening, and when the earth will get warm. Okay, suppose if some water level is there, depending on the radiation, the heat waves coming or maybe cold waves coming, the water get get the lower levels. The water level will reduce depending on the environmental factors. All the data has to be analyzed. Using Eagle IO board and Twilio cloud services, we can do that proper distribution of the water to the use cases. The water level of the river can be known by applying simple calculations using our machine learning aspects. And supply chain control, smart retails. What is the supply chain? NFC payments, intelligent shopping applications. In a future, when we go to the shopping, automatically some noise or maybe some sound will come. It will show that previously you have purchased some clothes from this location. You can go to that location only. If you maybe automatically some sideways displays will be showing that it will detect your face and automatically it will drive you to the particular location and it will suggest some suitable colors also. Okay, that's how the smart shopping or maybe intelligent shopping will come in future. Customer habits, preferences, and presence of allergic components from the previous data what we stored in the cloud when we met the health doctor. Depending on all those aspects, the shopping will be suggested for us. Smart product management, control of rotation of products in shelves and warehouses to automate restocking processes. Okay, this is how it will, using the camera, it will read the data and it will process, and depending on your height and color and nature and the previous data which is at the health center you have given that your allergies or maybe some based on that previous information, the machine learning which is unsupervised and supervised way. There are three ways are there for a classification and giving a decision over there. Okay, supervised and unsupervised and mixed one. It's like a combination of supervised and unsupervised. Using that third method, the feedback was taken from the previous experience and the current experience. It will suggest you the nice model using machine learning. Okay, reading this is also most important. Smart sensor technology monitors. Smart sensor technology monitors bee health and global pollination. Okay, this is also most important. Actually, I did one project for the monitoring the life monitoring and how many hours they are working for these bees in a day and how many hours they stay inside the nest. Okay, the honey bee nest, how much time it is taking. Generally, for the plant in one location, they will have this honeybee nest. Okay, in this, how much time they are going to stay, number of hours, and how much time they go away from that. That monitoring, how can we monitor? A person cannot sit and make it out, right? So we thought of, and the other parameter is that how much honey they produce per day, how much honey will be coming to the particular size of it, and or maybe when you are doing that pollination or maybe where they are growing it in those location, the area is fixed. Depending on that, how much it is going to generate in a day, we want to estimate. Okay. The prediction of that how much honey has been produced has to be done. When we came to know that some sensors embedding has the concept that embed a sensor to monitor its rest period, the honeybee rest period. Maybe on the nest also it may not be quite enough. It will be always placing on this nest area and working out. Okay, but out of the nest, how many hours it is working? Then we made some sensor such a way that this box this honey making boxes are there. Box inlet and outlet is there. Multiple number of sensors we made in the box inlet outlet. It's a two-way structure. Okay, this is sensor 1 and detector, and other one is sensor 2 and detector 2. This structure we have been developed, and when we say that this is a box, honey box, and the bee comes to this sensor first and moves to this one, that means it's coming inside. The time t1 will note down. When the honeybee is moving from this side to here, then it detects the sensor 2 is detected first and sensor 1 is the next, then it's a out condition. Based on this simple sensor concept, we are reading the data and analyze that total. It may stay within the nest around 4 hours or maybe 5 hours. Okay, after roaming around all around, and sometimes nearby wood plants or maybe flowers are there. Frequently, it will be moving in and out. Okay. What about at night? In the night, what they will do? And are they going to take complete rest in the night? That study and analysis we have to do based on the total performance and what is the size of the honeybee. Okay, that bee size detection also we can do. So many parameters we can try, because honey is an essential thing for curing and using for health improvement aspects. So many medicines they'll use, and health improvement for the daily use they'll use it. So this is also one of the important thing to monitor and give a prediction that how it is going to work. Look at the impact of carbon dioxide, oxygen, temperature, humidity, chemical pollutants, and airborne dust levels on the honeybees also has to be monitored. All these elements has to be monitored. Based on this condition, we can generate a lot of honey. Okay. These are the elements we have to consider and do. Logistics, quality of shipment condition, item location. Generally, this medicine we are ordering online. Some vaccine you are ordering online. That vaccine ordered online, it will go for the agitations, vibrations, strokes when a packet is thrown away. Okay, that a vaccine they will seal it here, and they fill this vaccine inside this syringe or maybe in the bottle. Okay, vaccine bottle, they'll keep it. This bottle has to be monitored properly during the shipment from customer to from the seller to customer. This medicine or maybe vaccine has to be monitored. Okay, what are the hesitations it has, strokes it has, and container openings and closings when it is opened, how much light is felt on it. Okay, light even how much temperature it is maintained. These parameters and all has to be analyzed. Okay, maintenance of the insurance purposes, also the cold chain maintenance also has to be covered to maintain its to retain its property, vaccine property. Item location, search of individual items in big surfaces like warehouses and harbors. Okay, in a ship harbors, you see that so many containers will be there. We need to identify. Storage incompatibility using the GPS data. They will do warehouses and harbors identification of the location. Storage incompatibility and detections, and fleet tracking in the storage incompatibility. When daily consumables are there, or something like groceries, okay, all tomatoes, vegetables, or maybe non-vegetable items. Okay, few things has to be consumed daily. Those food items, storage incompatibility has to be detected. Otherwise, so much loss will come. And the fleet tracking, control of routes and followed by delicate goods like medical drugs, jewels, and dangerous merchandise chemicals has to be monitored. Industrial control, M2M applications, machine auto diagnosis and assets control we can do. Indoor air quality monitoring we can do. Temperature monitoring, ozone presence, indoor location, vehicle auto diagnosis has to be done. And smart agriculture, the food quality or maybe the plant growth has to be monitored. The plant growth, the diseases you are getting. Here, some image processing, signal processing, using ML. Many people are looking at this and e-health point of view, this using machine learning, signal processing or maybe image processing only they are concerned. Where they can work out, where they can build some system. In greenhouses, they can build a system, they can create a sensors data using some collaboration, they can make a lot of data and maximize the production of fruits and vegetables and its quality using machine learning. Golf courses, maintaining that dry zones and water resources, and look for the greenery to get good environmental conditions. Meteorological stations network, study of weather conditions in fields, forecast ice formation, rains, drought and snow or wind changes has to be, meteorological conditions has to be monitored in agriculture system. Due to the moisture conditions, if a moisture is more, there is a chance to get more pests. Okay, more number of insects on the agriculture. Okay, compost, control of humidity and temperature levels in alfalfa and hay, straw and etc. In these elements, if any grass, okay, waste grass or maybe unused and straws are there, straw grass and all those things, the fungus formation will be more. So this microbiological agents contamination has to be reduced by having a good monitor. Smart handling, hydroponics and offspring care, animal tracking, toxic gas levels and several conditions we can make it and measure it, and energy and water use, remote control applications, intrusion detection system, art and goods prevention system. In all the aspects, ML is used. And finally, it comes to that e-health. And most of the people are looking at the health point of view and making it out. Here I am showing you so many opportunities are there. You can select one of these opportunities as a machine learning study area instead of this health area. In health area, using for EEG data, okay, EEG data, ECG data, or maybe EMG data, okay, and some pulse rate, MRI data. In all these aspects, using AI, ML, and DL, they have achieved a maximum level. Different trials, they're doing it, different algorithms. And when it comes to some analytical study on this, what is the mean square error you are getting with the synthetic data and real-time data? What is the intensity variation or maybe seizure detection in EEG, and in ECG, the estimation of the heart attacks using machine learning, it has been come to saturation level. I'm saying that some opportunities are there in different areas also, smart animal farming, some smart agriculture and domestic and home automations, all these are there. Here almost using ML and AML and CNN models, they are achieving 95% and 99% also in MRI and CT scans and some digital image pictures and digital video capturing and converting the pictures. They're using CNN and everything. They made, they reached to the some saturation point level. So when you come up with the EEG and ECG, EMG and MRI and some other medical aspects, okay, the detection can be done very effective using ML, but there is a less gap for the potential research on it using a CNN or machine learning. The research gaps identification is very tough and a big task in the e-health. If you want to get quick results, you can work out in all the given aspect areas and try to implement machine learning to these aspects. I'm not denying to you to work on e-health. You can work on other aspects to get a quick results, quick estimation. On a health aspect point of view, you implementing a machine learning to make some suggestions in the health point of view, some predictions in the health point of view, it already reached to the saturation level, almost to the saturation level. If any novel approach, and some people are doing machine learning based sports activities also. This sportsman care they are doing, and medical fridges controlling the freezer for storing vaccines and medicines and organic elements using blockchain technology. Okay, all the blockchain technology can be implemented to this patient surveillance using the blockchain technology, monitoring of conditions of patients inside hospitals and in old people's home. Okay, what is their condition? Using a smart IoT device, implementing a machine learning algorithm to it can say that when the elder people will fall, futuristic fall, or maybe futuristic fall means within 5 minutes or 10 minutes, some alertness will be given, and suddenly the elder people can sit down. If they get some alarm saying that you are going to fall, some people, elder people, they cannot make decisions immediately. People may not be knowing that. If you can make some algorithm to warn them, to give a prediction, and based on that prediction, the people can sit and avoid so much of damage to the organs or maybe to the body. Generally, when this fall is happened to the elder people, even in when they go for the toilet or to the bathroom or maybe when they are walking, if they have a fall sensation, they cannot make out anything. And if you can warn them 2 minutes or 5 minutes early, obviously they'll sit and we can avoid so much of damage. We can save the life. And ultraviolet radiation, measurement of UV sun rays on and warn people not to be exposed in certain hours. Even in India, we are having more sunlight, but many people are not using that UV sun rays in an effective manner. How much percent is required? So we are having skin diseases, skin allergies. All these things are more. And e-health point of view, this is a MySignal device developed at a low cost, and which is having interfacing of blood pressure sensing, SpO2 sensing, okay, pulse oximeter sensing, and glucose level metering, and spirometer, and alert patient button. Some options are there, and snore sensing option is there. Snore sensing measurement. All are interface to this device. This device will provide all this data. Based on this data collected, okay, airflow sensor to the nose and GSR sensor to the hand, gesture monitoring, hands gesture change, the fingers movement and all, ECG, cardiology estimation, EMG, okay, and EEG, okay, based on this we can get a seizure identification using EEG, and body temperature sensing, and the sound generators to alert, and body position sensing. If people are not sleeping in a proper way, the sound alert will come. If any one of these directly we can interface like this, and if any symptom is symptomic or maybe unessential thing is happening to the body, then immediately some warning will come and we can make it work. Okay. And coming to the aspect that where we can learn. Okay, I hope all of you by this time you already know all this. What is a machine learning and supervised learning and where it is used. Maybe using a Spark ML library, you will get all the database. From the database, you can compute and make out some sensible data. Okay, extracting patterns and fitting data to functions, classifying data, and all these things can be done with a supervised or unsupervised learning. Okay, and we need to say that what is a machine learning? It's a part of artificial intelligence and computer science, which focuses on the use of data and algorithms to intimate the way that humans learn gradually and improve its accuracy. Okay, one of the best example I can say that as a human being, along with our age, from born to now, we are all having different stages of learning. Artificial intelligence at one stage of life, machine learning at one stage of life, deep learning at one stage of life, and the future we may have systems which are having self-learning. Okay, I mean to say that human being is the one who is having artificial intelligence, and as when a kid is born, he will be in an artificial learning stage up to some 2 years or 3 years. From 2 years to 7 years, he will be having machine learning stage. Okay, artificial intelligence is there. What mother and father will feed, that will be understood. What we are speaking and what you are saying, that only the human being will understand. After that, from 3 years to up to 7-8 years, he will be into machine learning. He will make a classification, what to do. Okay, some decisions. He may not take own decisions, but he will make the classification and he will come to some predictions and conclusions. He may use that statistical methods and his own trained data and come to some predictions and classifications. The next, after 7 to 8 years time, he will be having his own learning, and there he comes to that data, that deep learning will come. The deep learning comes to that kid or maybe to the boy with a self-learning, or means gathering the information. One of the best example I'll say that artificial intelligence is it visible what I am writing? Is it visible or not? No, it's not visible. Okay. AI, ML, and DL, deep learning, these three stages in our human life you'll be having. When the kid is born, maybe some 2 to 4 years, and 4 to 8 years, and 8 to beyond this, and self-learning will come after 15 or 16 years of age. Okay. Now, one of the best example here is that If you say to the boy or girl, the small kid who is around 2 to 4 years, if you say that something is not good, okay, the fire will burn. If you say, he will just remember that. He don't try anything. It will burn. He will remember that. That is artificial intelligence. We just feed that and the fire will burn. And machine learning is that when you say that fire will burn their hands or maybe to the body, then the kid wants to do that. What all things will burn? What will burn? It will. He will be trying to understand that what is going to burn. And at the stage of deep learning, what he will do that he will try to touch the fire, and when he touches the fire, automatically he will take that feedback. From that feedback, he will understand that okay, fire will burn. Whatever you feed previously, that may not be important for him. In a deep learning, he will try and get a feedback from that. That trial of feedback he will understand and make sure that we should not touch the fire, and he will remember. And after that, the super learning it will come, or maybe self-learning. Whatever we speak according, or maybe we load, or maybe he learned from that. Beyond that rules, he want to make some decisions. Okay. See here, artificial intelligence, there is no decision. Machine learning, some decision is there. And deep learning, some decision with the feedback data. With the current data and with the feedback data, in a deep learning, you will have decision. In super learning, including all this AI, ML and DL database, he may have, he or maybe the system will have its own decision making. In a deep learning, they'll make some good decision based on the feedback. In a super learning, including all these things and the futuristic plan estimation, the good decision might come up over here. Machine learning systems can learn and improve with the historical data, time and experience, and bridges theoretical computer science and real noise data. There is a in a real-time basis, so much of noise data will be there. Okay, and theoretical modeling we feed, and there is a real-time data, some analysis it will do, and it will come up with a proper estimation to some value. And machine learning in real life time, most of the first factor they are looking into Netflix only, suggesting and all. And after that, Google DeepMind and challenges and KBA. Okay, some of the things are happening depending on our previous recorded data and current recorded data, and prediction in so many aspects, either in a shopping or travel or maybe in a companies. Okay, different aspects it is working, and there are three types of learnings: supervised, unsupervised, and combination of both. Unsupervised learning, there are not a predefined and known set of outcomes. If you see that, if you take a set of data, some bowlers and batsmen, generally we see that a cricket, 11 players details it want to collect, player name and score. Okay, depending on the score, we can segregate a few people here and few people here, few people here. Now we want to rank them. We want to classify them. Who are the bowlers? Who are the hitters? Whoever score high, they are the hitters, batsmen. Whoever score less, they are not batsmen. They might be having other thing like a bowling. And these people are not good at bowling, and these people are in a bowling aspect. If you take in this side, this is a low bowling and this is a high bowling aspect. These people are having less score and bowling ability more. That's how this unsupervised data, or maybe unpredicted or unpredefined, not predefined data, some set of outcomes we can make it out. Look for hidden patterns and relations in the data. In all the data, we'll find out that the patterns, and based on that, and somewhere here, these people are, if we say that this green color, these people are semi bowlers and semi hitters, batsmen. That's how we can classify. It's like a whole team members, like a batsman, bowlers, and the people who can do managing. Sometimes some bowlers may hit high, and some bowlers may not hit, or maybe some bowlers may not do bowling properly. Okay, the typical example, the clustering we can do all together, then only effective way it will come. And supervised learning, if you see that, for every example in the data, there is always a predefined outcome. We'll say that, okay, he's a batsman, he's a bowler. That's it, it's all predefined. Then obviously, when the score is less, okay, it was happened only by the bowler. When the score is very high, we can say it is happened by the batsman. And within the batsman again, we can say that some people may hit 100, some people may hit 50 only. If nearby, if a batsman one hits near to some 90 or maybe 120, directly we can say the batsman name. We can predict it. Who, based on the score, we can predict it. Maybe he is the batsman. And whoever score around 40 or 61 or maybe 49 near to this value, then the second batsman's name we can get. Suppose if 2 wickets were taken by one bowler, the bowler name can be predicted automatically. Models the relations between a set of descriptive features and a target, and fits data to a function. So many functions we'll use, and from this supervised learning, classification and regression can be done. And classification means we can give that who are at the top score and mid score and low score, that predictions we can make it out. It predicts which class a given sample of data or sample of descriptive features is a part of discrete values. The features we can add. If you take the apple, and that the apple features are round, we can say red or green apple, red or green apple, we can say the shape round, we can say, and color we can say, and what it is it a fruit or flower, we can say. This is how some list we can give it. Based on this list, a classification will have. Regression means predicts the continuous values. Continuously, it is going to predict different values. In a supervised learning, this regression and classification can be done. Even for the continuous signal, when you have some data like this, continuously some EZ or EMG, some data, if you have that, from this data, some predictions we can make it out. And this machine learning as a process, it will have defined objectives and data predictions we can make, and model building is a part, and model evaluation and model deployment, and then coming to the accurate objective definement. Define measurable and quantifiable goals. Use this stage. This quantifiable means identifying, classifying is one of the goal that has to be defined properly with the given vector representation. Use this stage to learn about the problem. First we have to feed some data and it will learn the problem, what it has to do, classification of either fruits or flowers or something. And normalization, data preparation has to do. Normalization means we have to provide that does it comes under fruits or maybe vegetables or maybe flowers, or that categories wise we have to do, and transformation we have to do, and missing values we have to ask. Data preparation, if any missing values has to be added, how many parameters we are keeping, on outliners has to be given, shapes, and model building, data splitting, features engineering, and estimating performance, evaluation and model selection has to be done. And model evaluation and model building comes under this. And the model deployment, study models accuracy work better than a Navy approach and previous system. Do the results make sense in the context of problems? Thus the machine learning process will start like this. And in the process of ML, the data preparation will take place from the objective to this level. The raw data has to be taken out. Missing values, error values, different scales, dimensionality, types, and problems, and many others has to be done. Data transformation, scaling, centering, and skewness, outliners, missing values, and errors identification. And data is going to be ready after this raw data and data transmission process. Undetermined time on data preparation should not be taken into consideration. The feature engineering in the process, we will see that vapors and the filters. Okay, in this filters evaluate the relevance of the predictor and based normally on a correlation. Okay, we need to make a normality in the system to say that identifying the parameters in the process. And it will work depending on a decision process, an error function, and a model optimization process. Generally, we see that generally I'm trying to open the video. Yeah, when you see that one, the machine learning working process based on three parts. One is a decision process, another one is an error function, and next one is a model optimization process. A decision process in general, if you take, it will have make a prediction or classification. That is the first decision process. We need to either do classification or prediction. Based on some input data, we can be labeled or maybe unlabeled by the algorithm, will produce an estimate about the pattern in the data. Okay, the pattern estimation has to come after the modeling phase. Next one is after the filtration model, an error function serves to evaluate the prediction of the model. If there are known examples, like a error function can make a comparison to the existed models and give the accuracy of that model. Okay, that normalization of the data based on the correlations will be done, and we can have a less error functionality after the decision process. And if the model can fit better into the data points in the training set, then weights are adjusted to reduce the discrepancy between the known examples and the model estimated from the previous decision model. So this optimization process is the last process we can have it. in the real world, we see that speech recognition and customer service and computer vision and recommendation engines and automated stock trading are the most real world machine learning challenges. Along with those things, few other things actually which are related to IoT applications to generate the data I have shown today. And challenges of the machine learning, if you see that technological singularity has to be checked, and AI impact on jobs, and privacy is going to reduce a lot even by improving this machine learning. Bias and discrimination is happening more. The instances of bias and discrimination across a number of intelligent systems have raised many ethical issues. Okay, regarding the use of artificial intelligence, we see that so many ethical issues are coming, are going to be faced in a future. Those are the main challenges, and the principles of trust and transparency has to be improved using a machine learning, and there are accountability for the legislation to regulate AI practices has been uh, considered while we do some machine learning process to any kind of data. Okay, there is some model that IBM is providing good amount of IBM cloud to the machine learning services. So many services are available in the IBM that will help either entrepreneurs or maybe independent researchers by giving a cloud's native data and giving a certain AI platform to help all the people. And IBM Watson machine learning servers offer simple installation on any private or public cloud sectors. Okay, if you want to work on the raw data which is available from the data sets, you can take out and work it out on the IBM cloud services. That is most important. And few more things are there, different examples what you have to study. Okay, with this I conclude the presentation. Thank you all, and try to make it beyond the observation. You have to work it out to grow further. If any queries are there, please. Hello, Ramlin Swami, are you there? Anybody is online? Any questions? Okay, thank you all. Possible, we'll see again.
Thank you, sir.
Yeah, welcome. If no more questions, no questions are there, I can leave.